All right, this second method is where you identify the point on the unit circle that's described by the given information, verify that the radius is equal to 1 because the radius on the unit circle is a 1, and then we can use the x, y, r definitions of the trigonometric functions to find the rest of the ratios. So this is the same example that we did for method number 1. So our given information is the same. Sine of theta is 3/5, cosine of theta is -4/5. And so that means that the point on our unit circle is going to be cosine of theta, sine of theta, so -4/5, 3/5. Now I can verify that the radius is equal to 1 using the equation for a circle with a center at 0, 0. So if I put in -4/5 from my x value in place of x and 3/5 in place of the y value, then I can calculate there. So I would need to square those fractions at this point. If you want, you could pause the video if you already know how to do this and then try it yourself. But if you're not sure how to square fractions, stay with me and I'll explain it. To square a fraction, you do it just like you square everything else. So you multiply something by itself. So -4/5 squared would be -4/5 times -4/5. And when you multiply a negative times a negative, your answer is positive. And when you're multiplying fractions together, you just multiply numerator times numerator. So 4 times 4 is 16. And denominator times denominator, 5 times 5 is 25. So -4/5 squared is 16/25. So similarly, with 3/5 squared, 3/5 times 3/5 would be 3 times 3 over 5 times 5. And then when we add the fractions together, we do have to have the same denominator. These already have the same denominator, so that makes it very easy addition. You just keep the denominator and you add the numerators. So 16 plus 9 is 25. All right, so 25 over 25 is equivalent to 1. And then to solve from there, we would take the square root of both sides, which technically, since when you're doing that algebraically, use a plus or minus there. However, this r is a radius, which is a distance measurement from the center of a circle to any point on the circle. Since it is a distance, the only part of that answer, the plus or the minus, that makes sense would be just the positive. So r does in fact equal 1. Now that we've verified that, we can go ahead and answer the rest of the questions here. So I'll scroll down just a little bit. There we go. Okay, so I'm going to write down what I know. I know that x is equal to -4/5 and y is equal to 3/5 and r is equal to 1. So for tangent, in terms of x, y, and r, tangent is y over x. So my y value is 3/5, my x value is -4/5, and when I'm dividing those, of course, I'm going to show one less step this time. That's the same as multiplying by the reciprocal of the denominator. The 5s would then cancel. So on top, I'd have a -3, and on the bottom, I'd have 4. So my tangent of this theta would be -3/4. Next up, I've got cosecant of theta. So cosecant of theta is, in terms of x, y, and r, it's r over y, the reciprocal of sine. So in this case, my r, of course, is 1. My y is 3/5. 1 divided by 3/5 is the same as 1 times 5/3. And 1 times anything is just itself, so that one's just 5/3. Secant of theta in terms of x, y, and r is r over x. So again, my r is 1. My x is -4/5. 1 divided by -4/5 would be the same as 1 times -5/4. So that would be just -5/4. And then finally, I've got cotangent. A cotangent in terms of x, y, and r is x over y. My x is -4/5. My y is 3/5. And so I'll show some extra steps on this one. So that would be -4/5 times the reciprocal of 3/5, so 5/3. And the 5s would cancel out on that one. So that leaves me on the top just -4 times 1 over on the bottom 1 times 3, so -4/3. So my cotangent would be -4/3. That's your second method using x, y's, and r's.